All right, we can get started. Hello and good afternoon, everybody. Welcome to a session on how you can secure your CI/CD pipelines against emerging attacks. It's a pretty hot topic that attackers have been actually focusing on this area, particularly in the last year or so. As companies are focusing on strengthening our security, they're often forgetting about this part. This isn't a top of mind. Most companies secure their applications, their cloud, their infrastructure. They'll spend dollars securing everything else, but this is not something they've been focusing on. And it's fair because automation and CI/CD is relatively new. I mean, it's picked up pace in the last 10 years. So we're going to talk about some of those challenges today. But before we do that, a little bit about me. Farshad Abasi. I've been in the software and security business for about 27 years. I spent half of my career building software. I've worked at startups, large enterprises. I could truly be called a full stack engineer. I've built drivers, so that's pretty low level, modified the Linux kernel, but I've also built web applications and e-commerce platforms, pretty much covered it all. I'm the CEO of Eureka, DevSecOps, and Forward Security. We specialize in application security, DevSecOps. Before Forward Security in Eureka, I was the principal security engineer at HSBC Global Bank. I was there for 9 years, and that was my first pivot into security. So prior to that, I was just a senior software engineer, building software, doing all that. Pivoted into helping people secure their software. A lot of bad things happened to me during my time in software development, so I'm taking all those lessons learned and helping developers not to make the mistakes that I made, not knowing what I needed to do. So, lots of experience in AppSec, built the HSBC's global application security program, rolled it out and scaled it globally. I'm always happy to talk about that experience and the challenges we had, because financial institution, I remember Wade yesterday mentioning at the speaker dinner that, when you work in fintech or financial places, your hands are tied. You can't just go and grab the latest technology and play with it. There's a lot of limitations. I know all about that. Spent 9 years in that world. I'm also an instructor at a local college in Vancouver. That's where I'm from. I'm from Canada. I've been teaching security for 22 years. And I also organize conferences. Funny enough, security conferences. So there's a Pacific Northwest conference that I help organize, sponsored by OWASP, which I'm sure you've heard of. And we also do B-Size Vancouver. And I really love anything to do with computers. It's my passion, and security is my other passion as well. So let's talk about what we're going to do today. I'm going to start by setting the stage and talking about the current CI/CD security landscape. And then we're going to spend the bulk of this presentation on what the top 10 CI/CD risks are currently. And then there'll be some takeaways for you and some time for QA. If we don't have time for QA, I'm happy to chat after the session. So the CI/CD landscape is evolving, things are changing, and attackers are taking advantage of it. In the modern software development really depends on CI/CD, right? Like we had Agile in the old days, and before Agile there was Waterfall. In Waterfall there was no CI/CD. You had different stages, you built you did your requirements, you did your design, development, testing, and you delivered the software. Then came Agile. The goal of Agile was to bring the developers closer to the clients, to the business, and CI/CD was a huge part of it, and that's where automation came in. And then as Agile moved on to become DevOps, where not only was the development team closer to the client, but we also brought the ops team to the party. Then you also built further on top of CI/CD. So it's pretty important in the backbone of things. And I don't know if you guys remember, there was a shift when Docker and Kubernetes came. It was a game changer. It really expanded the CI/CD universe. Docker really changed the game, got everyone to adopt DevOps and all that kind of stuff. And we rolled out all these pipelines that allow our developers to quickly integrate stuff and then deploy them to an environment. But that gives them quite a bit of power, and in a lot of organizations, they're not really mindful of that, and developers will have access to pipelines that can roll things into production or other things that we're going to talk about here. So really, we need to be mindful of how these technologies are used and secured in our environments today. And we'll talk about how you can do some of those things. And of course, whenever there's a challenge, there's an opportunity, right? And so, before we dive into the top 10 issues, I just want to kind of set the tone and talk about 3 key breaches that you may have heard of, and then we'll deep dive into them as we go later. But the first one is SolarWinds, right? In December 2020, this blew up, and it was bad. It was really bad. And It was so bad that the US issued an executive order, right? So it was like, I think, early 2021 or so, they put out an executive order that said, hey, enough is enough. Software is causing a lot of problems. This SolarWinds was really bad. We need to deal with software supply chain problems. And in fact, that executive order mandated NIST to put out some guidelines on how to build software securely and how to test it properly, right? Because most people, like, you know, I'm sure a lot of people that I talk to, they don't really know how to test software. They just say, hey, Farshad, I need a pen test. My question is, pen testing doesn't really identify your software problems very well, because pen testing works well for networks and for infrastructure, where, you know, you basically have a bunch of known CVEs or vulnerabilities, you look for them in the environment, and you go, hey, you have these problems and I can exploit them. But for software, we're writing a lot of brand new code. The CVEs aren't even published yet. So if you're relying on the pen testing methodology to find CVEs and tell you, guess what? You're only probably going to find about a third of your problems. To test software, you have to do a lot more, but that's not the topic of this conversation. But essentially, that was a game changer. That US executive order really focused on software security, and SolarWinds was one of the drivers for that. And you know, we'll talk about the details of it, and it relates to one of the top 10 issues. Then there was the code cover breach. In the code cover breach, there were secrets that were exposed through the CI tools, right? So they didn't manage their secrets very well. They had them embedded in a Docker container, and people found it, and then they were able to log in and modify. Again, we'll go through the details in a little bit as well. And then finally, there was the dependency confusion attack, right, where attackers realized that if you have a private package, if they know the name and they create a public package, you'll probably fetch that one before you do that. And again, we'll go through the details as well. But these were the three key attacks or types of attacks that really prompted this talk and the OWASP's top 10 CI/CD security risks, which I encourage you to check out. By the way, I'm sure most of you heard of OWASP. They have the classic OWASP top 10. As of about a year ago, they've also published a top 10 for CI/CD risks. I highly encourage you to check that out and make sure that if you are using CI/CD, that your environment is protected against those top 10 risks. So what are those top 10 risks? Let's talk about them. So these are, we're going to dive into them, but first, understanding that these top 10 risks is really foundational to securing your CI/CD, and these can range from insufficient pipeline security to improper configuration and everything in between. And each of these risks has a direct impact on the integrity, availability, and confidentiality of our development and deployment environments, right? You all have heard of, hopefully, the CIA concept, not the US agency, but the confidentiality, integrity, and availability. And at the end of the day, those are the three things that can go wrong. And for example, consider the risk of insufficient flow control mechanism, right? So if you don't have proper controls, unauthorized changes could make their way into production. And a couple of attacks, a couple of breaches that I just mentioned have suffered from that. Another example is inadequate identity and access management, highlighting the need for strict access controls and identity verification. So that's quite important. So mitigating these risks involves a combination of best practices, including implementing robust access control, regularly auditing your CI/CD pipelines, making sure that people have the right access, that the secrets are handled appropriately, and all the components of the pipeline are securely configured and maintained. So you're probably all wondering, okay, what does that look like, right? So let's dive in. So here's the first one. Insufficient flow control mechanisms, right? What is it? Why is it important? We're going to look at exactly how things went sideways for SolarWinds and CodeCov. So in the SolarWinds case, what happened is the attackers replaced the file with another file. That other file had some malicious, code in it, and that simply it went through the pipelines at SolarWinds, and it got bundled and packaged and signed and then delivered to all their Orion clients, right? So they didn't have flow control. I mean, they should have had some mechanism where it's like, oh, hey, this file got uploaded or replaced. That triggers some sort of a review, but that didn't happen. So the flow control mechanisms weren't tight enough, which resulted in them having that massive problem. And this file made it into the way of thousands of organizations, all because the flow controls didn't catch the bad stuff. What about CodeCov? How many people have heard of CodeCov? Okay, a number of you. Actually, I'm curious, how many people are involved directly in the DevOps side of their organizations? Okay, fair number of people as well. Thank you. So CodeCov was a tool that looked at your coverage, testing coverage in your code, right? So it had an agent that runs in your CI/CD runner. Most CI/CD platforms, all of them, usually have a runner where the tasks are executed in that runner. The runner could be a virtual machine or it could be a container, right? So in the case of CodeCov, they had an agent that agent would run, and then it would get some metrics and then upload those metrics to CodeCov, right? Now, that particular agent was a container, and then in that container image, there was some secrets embedded, which CodeCov didn't catch. Those secrets allowed that agent to, it was in the Google Cloud Storage bucket, so it could go and fetch this bash uploader script. The bash uploader script was a script that would upload the results to CodeCov after the analysis was done, right? So the attackers went and downloaded that container, analyzed it, found the secrets in there, and then they were able to use those secrets to log in to that Google storage bucket, right? So when they went in there, they found that bash script, and of course they just modified it slightly so that not only does it upload the data to CodeCov, but it would also upload a bunch of stuff to them. Now, what kind of stuff did it upload to them? Really bad stuff, because essentially in your CI/CD runner, there's a bunch of environment variables, right? What kind of environment variables? Well, typically there'd be credentials to log into your GitHub, for example, and other things. So they modified this bash uploader script that would dump the environment variables for any of the clients that are running this CodeCov agent and upload it to the attackers, right? Pretty bad stuff. So, all of these highlight, underscore the chaos that can ensue from inadequate flow control. So to combat this, you need to do a few things. How do you mitigate them, right? So to combat this, you need to do some things like setting up some automated guardrails, like for example, looking at what changes have happened. And these are, so to identifying that if anything has been modified, and additionally having strict access control and role-based permission. Why did that credential allow someone to go and modify that script? They should have just, if the intention was just to go and fetch that bash uploader script, the credentials should have had limited access so that you can just go and download it, right? Like a read-only. Why did they make it a read-write? They didn't follow proper access control or proper security principles. And so that's really important. And it might slow us down a little bit, but it beats dealing with the mess later on. And we're also making sure that only the people who really need access can get access to it and modify it. So that's really important. Also, let's not forget about the importance of having a software bill of materials, using code signing where possible, and monitoring and alerting if there's anomalies or changes, right? But really the big control in this case would have been making sure that you have that flow control, that you have the right checks and balances, that if someone changes that bash uploader, that they can't just go and change it. There's some sort of a workflow required. Someone has to approve that and goes through change control. So that is number one. What is number two? Guarding the gates. So this is about inadequate identity and access management, right? And identity access management is a sort of broad, encompassing term, but here the focus is really making sure that you have the best practices for IAM. And so what example do I have for you? Let's talk about PHP. So in 2021, in March 2021, someone breached the PHP Git server, right? You're like, why did PHP run their own Git server, right? Why didn't they use GitHub? Well, they did later, but in the beginning, they were running their own Git server. And they hadn't really, there were certain security holes in there. The attackers were able to, and this is not confirmed, but what they're saying out there is that the attackers were probably able to dump the database with all the username and passwords, and then they just used an existing user's credential because they had it. And there was no multi-factor authentication, nothing was really hardened. So once they got the credentials of a couple of real users, they were able to log into that Git server and do bad things. So what did PHP do right away? Well, first of all, they went to GitHub. So that someone else is going to manage that, secure it, configure it, but also GitHub supports multi-factor authentication. That would have prevented this problem, right? Because even if I get your username and password, if there was MFA, I would have to also have the device that provides the second factor. So combination of those helped them really address that situation, and that's something they should have done to begin with. But really, the lesson learned here is that you need robust access controls. Strong authentication is really important. Make sure that weak passwords are not accepted, and you're also augmenting it with multi-factor authentication, adding an extra layer of defense that could make all the difference. And of course, principle of least privilege, right? Like we just talked about CodeCov, always make sure that your users only have the level of access that they need. Now, this is a lot easier said than done, right? Because I wear two hats. Like as I mentioned, I run two companies. We have a product company where I'm building software, and then I have a consulting company that I'm consulting to clients. And if I put on my developer hat, this stuff is not easy. Like if I put all this access control, all this stuff is going to hinder the speed of development. And that's fine while you're building things, but the moment you're transitioning from your build environment to the production environment, you better make sure all the checks and balances are in place. And so that's the lesson learned there. Now, dependency chain abuse, I hinted at this in the beginning, right? Some people call it dependency confusion, some people call it dependency hijacking, but let's take a couple of minutes and tackle dependency chain abuse. This is about the sneaky way that attackers mess with the very building blocks in modern software to compromise their application. It's pretty tricky, where the beta is a familiar package name that they know, and the hook is the code that no one expected to run. Right? And modern software heavily depends on dependencies, for the lack of a better term. Back when I started building software in '97, we just wrote everything. Very few packages. There were libraries, don't get me wrong, but there wasn't a lot of stuff available. So you had to write a lot of your own code. And sometimes you wrote code that you shouldn't write. For example, I needed to encrypt some stuff. This is in 1998. And I wrote my own encryption algorithm. Bad idea. Don't ever make your own security stuff, right? Like download someone else's. I was naive, 20-something. It was like, oh, here's the RC4, RFC. I'm just going to write this algorithm, my own implementation. Bad idea. There's lots of vetted libraries that you should be using for anything with security, right? Don't ever make your own. But as the years have gone by, software is more and more dependent on dependencies. And in fact, if you look at modern software, most of them are built by aggregating a bunch of NPM packages and modules and things like that. And then you write a bit of code to glue it all together, right? Especially in the enterprise. So it's important to make sure that you're prepared for this kind of thing. And there was a case a few years ago when someone tricked a bunch of high-profile companies like Amazon, Lyft, and Slack to use the dependencies that were vulnerable. And essentially, they uploaded a malicious NPM package on public repos with names identical to the private packages. The unsuspecting build systems, then they go and fetch, because the order is like, hey, if it's available on the public repo, patch that first before you, download the private version, right? So the build systems went and fetched the dependencies from the public repos, and boom, the damage was done. They were able to execute malicious code on the CI nodes, which then allowed the attackers to move laterally within those companies, right? Pretty bad. So how do we deal with this? You got to make sure that you have. Scrutinize every package and ensure that your build system is fetching the right one, right? Use package.lock and Node.js if you can. Maintain a list of approved packages, but also have your own artifact repository, right? So at HSBC, that's the direction that we were going. At first, I remember developers were like, hey, this Node and all this stuff is sexy. We want to use React and NPM packages. I was like, this is kind of brand new territory. This was 5-6 years ago when that was gaining popularity. And then what you should be doing is rather than going to the public repositories and getting those packages, set up your own artifact repository where you cache those packages and they're vetted by the security team. You can use platforms like, and again, I'm not affiliated with JFrog or any of that kind of stuff, but they have a platform called Artifactory, right? You can put all your vetted artifacts. They'll even do software composition analysis. So then instead your developers going to the public repositories to fetch these packages, they can go to your internal one that you've set up that contains vetted packages by your security team. And also, we want to enforce the use of internal proxies to filter what comes in and out. Verifying checksums and signatures is really important, if that's a possibility for you, to make sure that the packages are authentic, and then lock down the packages to the versions that you've vetted and you trust. And of course, you should always learn from the high-profile hijinks as well, right? Like that's one of the things, that's one of the recurring themes in this presentation is always look at what happened to others and learn from that so that you're not the next news headline. Okay, the next one, number 4, is poison pipeline execution. There are two different kinds of this. There's like a direct one and an indirect one, right? And so what this is about, it's critical to grasp how these pipelines, the lifeline of our processes, can be turned against us. We've all seen real instances where attackers have exploited this. For example, they've used GitHub Actions to perform credential theft by modifying pipeline configurations to fetch AWS credentials, or they've modified Jenkins configuration to to execute malicious commands through pull request. Now, what is the difference between direct and indirect poison pipeline execution, you might ask, right? Direct is where you haven't tightened your permissions. I'm a developer. I just go to your Jenkins and I'm able to fetch secrets and directly modify that pipeline to do something bad. I might add a task or a step in that pipeline. Hey, you're doing 1, 2, 3. I'm going to add step 4. Step 4 is go and fetch the credentials and send it to me, right? That's because you haven't locked down the pipeline configuration. But there's an indirect one. Indirect one is about the things that the pipelines use, right? Because oftentimes you might have let's say you have a CD pipeline. That CD pipeline runs a bunch of tasks. One of those tasks may be to go run a shell script, right? If I go and modify, let's say you've locked it down, so I can't change that pipeline in Jenkins, right? But you didn't lock down that shell script. So what I'm going to do is I'm going to modify that shell script so the pipeline, I can't touch it, but it will run that shell script, and then that shell script has been modified to send me environment variables or do something bad. That's indirect because I'm not directly modifying the pipeline, but I'm modifying something that the pipeline uses. So, this is bad. What's our defense strategy around this, you might ask, right? How do we protect ourselves? Well, several things. So first you have to understand what poison pipeline execution is, right? It's not just a funny word, PPE. It's a pretty important topic. We need to be aware of how many attackers can poison the pipelines, either by directly altering the CI configuration or indirectly through the manipulating the scripts that are used. Make sure that every change to the pipeline configuration or associated scripts that are used goes through some sort of code review or configuration change management, right? If you've just left it open, probably going to happen to you. So we need to make sure that the CI/CD systems are configured to prevent unauthorized modifications. And then if there's any supporting scripts and things that are used, we make sure that those go through the right change control mechanisms. So talk about a couple of examples of how people have modified GitHub Actions in Jenkins. So really be vigilant about that. And if you just implement strict review processes and secure the configuration, you can protect yourself against poison pipeline execution. All right, number 5. So what is that one about? This is insufficient PBAC. Again, it sounds like a funny word, but it's pipeline-based access control. So really, what this is about is it's about looking at how your access control permissions are set up on a highly sensitive project. It dictates who can do what, ensuring that only authorized people can do what they're supposed to. You might be asking, hey Farshad, what's the difference between this and identity and access management, right? Really, identity access management governs user access systems at a broad level, but PBAC really looks at that, zones in on the actions on the CI/CD process itself and about the access control and fine-tuning those access controls, right? Where identity access management was like, hey, do we have 2FA? Do we have strong passwords? Sort of a broader category, where this is specifically honing in. How have I set up my pipeline access? What does it have access to? Who has access to it? And things like that. A prime example that sheds light on this, alongside IAM, is the CodeCov breach, right? Let's go back to CodeCov. I don't mean to pick on them, but there was a bunch of problems that relate to this. And it wasn't just a failure of identity verification, but it was also highlighted a gap in controlling what authenticated users could do, right? As I mentioned earlier, why did that set of credentials have access to change that script, right? They hadn't done the access control analysis, right? So if they'd done that, then there would be a read-only credential, and they would only be able to download that script and run it appropriately. So what can we learn from it? Basically, it's about implementing detailed access control, specifically for the CI/CD pipeline activities, right? So really analyzing what activities are happening across our pipelines and who should have access to it. What I usually recommend to clients that I work with is create a roles matrix, define, and always do roles-based, right? Like never directly assign users. That's like security 101. You don't ever do user-level permission assignments. Always do it at a group or role level, and really identify how many groups or roles do you have, and then in that matrix, one dimension is my roles, and then the other is the type of activities, and then you can determine who has what, and then once you've created that matrix, it makes it a lot easier to implement. So yeah, that's really important. And let me just see here. We talked about CodeCov. Yeah, so essentially, if you strengthen your PBAC measures, it's not just enhancing your security posture, but it's going to proactively help prevent unauthorized pipeline manipulation to make sure that your CI/CD processes are both efficient and secure. Number 6, insufficient credentials hygiene. This is about cleaning up your act, right? Like people, I read about this almost every day. Someone had hard-coded credentials somewhere. They didn't manage the keys and secrets. On a regular basis when we do assessments with our clients, this is a problem. We identify that they're not managing credentials appropriately. So let's talk about that and how that can be impactful. what if you had your keys to the vault scattered all over the place? How secure can your vault really be? So our pipelines are full of secrets, right? Like we have API keys, the pipeline might connect to another system. There's a lot of interaction with other systems that happen. There's keys, tokens, passwords. They're everywhere, from environment variables to our CI/CD tools to deployment scripts. We're using those credentials. But when these secrets are mishandled, that's when problems happen. So we've talked about the code cov breach. In that case, they exploited the exposed secrets that were in that Docker container to siphon off sensitive data. But what about Travis CI? Who's heard of Travis CI, by the way? Okay, a few people, not bad, right? They had it happen to them twice. They didn't learn the first time, they got breached twice. So what happened is they were logging the credentials, right? Like the credentials were in logs, and then people saw the logs and they're like, hey, there's really sensitive credentials in here. And then they thought they fixed it, but in 2021, it was back and people found secrets in the logs again. So they didn't really fix it properly. And that's actually a big lesson learned in security, is when you fix it properly and do it once, rather than quickly patch something we haven't really thought it through just to deal with a fire. And I know it's really stressful when things are burning and there's that fire going on. You want to deal with it as quickly as possible. But also keep in mind that if you don't deal with it properly, you're going to have another fire in your hands like they did a little bit later. So how do we avoid these pitfalls? Be mindful of your secret management, right? Make sure that you know where your secrets are. You have an inventory, right? I do this exercise with clients. We call it a security design review. And I go through various things. I go through the architecture of their software. I look at how they do authentication. I look at how they do authorization. And one of the things that I look at, one pillar, is key management. And I can safely say that 80% of people that we work with aren't handling key and secret management properly, right? Hey, if you're in the cloud, you got a lot of benefits. If you're in AWS, you got Secrets Manager. In Azure, you have the Key Vault. Cloud provides you a lot of really nice capabilities to manage your secrets, but we're talking about CI/CD here, and most of these CI/CD platforms also have secret stores that are pretty good. And I know a lot of you, probably most of you are all working in the financial sector. It's really important to do it properly, right? Because I know that HSBC, we were required to use FIPS 140-2 compliant HSMs to protect those secrets, right? And some of these platforms have the ability to connect it with an HSM and wrap your keys that way. So be mindful of it, but even if you don't, at least you have that good level of protection by using the secret store that come with some of these platforms. But really do a regular audit. So it all starts with your inventory, like knowing what keys and secrets you have and where they are, and then from there you can figure out whether you're appropriately protecting them or not. And also do scoped access. Make sure that each secret is accessible by only the parts of the pipeline that need it, right? Because if you allow any pipeline to access any secret, that's not going to be that great. Maybe you have a pipeline that developers use to deploy stuff into your staging environment. That pipeline should not have access to the API keys that are used in your production environment, right? And hopefully you're using different API keys for your production versus your staging environment. But those pipelines shouldn't just have a free-for-all access to everything in the secret store in your CI/CD platform. So make sure you tighten that up. And whenever possible, use short-lived and dynamic credentials rather than long-term API keys, right? So OWASP has a standard called the Application Security Verification Standard. If you have not heard of it, I highly encourage you to go look into it right away. Because a lot of organizations don't really know what security requirements to put into their application, right? Like at HSBC, me and my team had built our own software security standard and all the controls. It was a lot of work, and we had to update it every couple of years. It was not fun. But come OWASP ASVS, it does that for you. It's a crowdsourced list of security, application security specific controls, and it's really nicely categorized into like what you need to do at the architecture level, what you need to do authentication, session management, authorization, data input validation, all that stuff really nicely. So, and one of the things it says is that don't use long-standing API keys, right? And I think that recommendation is gaining broad adoption. So in the old days, we would just use an API key that lasted forever, but now what you should do is use something like OAuth and get a token that allows your CI/CD platform to access that service for a certain amount of time, and then you have to renew that token. It's not as convenient, right? Like, because API keys are nice. You just put it in, and it just stays there forever, but also not great for security. So you can kind of do a balance, maybe have the tokens expire every month or something like that, so you're refreshing them on a regular basis. And education and tools is really important. So empower your teams with the knowledge and tools to detect and prevent secret leakage, including using secret scanning code tools. I know GitHub Enterprise has those features built in. There's also a lot of really good vendors out there that provide secret scanning and all that, and learn from others. Again, I'm going to keep repeating this because it's really important. Look at what happened to Travis CI. Make sure that doesn't happen to you. Make sure you're not logging secrets, right? It's funny because I remember, was it at HSBC or somewhere else, developers were like, hey, they were logging some sensitive stuff, and then they were going to encrypt that. Like, okay, well, we're going to put these sensitive data in the logs, but we'll encrypt it. It's like, no, sensitive data should not be in the logs to begin with. If you need to have it for troubleshooting, de-identify it, right? Like, if you need to log something sensitive and it needs to be there, de-identify it, scramble it, so the characters are there as a string, but it doesn't represent the actual data, or you can tokenize it and then be able to look it up what the actual value was. But don't ever log that stuff, even encrypted. It's not appropriate. Yeah. Learn from those, make sure that doesn't happen to you, tighten your grip on how you manage credentials, and make sure you have the right hygiene. And clean up your act if your act is not clean. The next one, number 7, insecure system configuration. This is the Achilles heel, right? And you can see there, if you've got a nice Nissan car, they make great cars, but they weren't really aware of how to secure some of that stuff properly. So, in the realm of insecure system configuration, the devil is in the details. Misconfigurations like default settings, lack of updates, and improper access control, they all serve as a beacon for attackers. And these things, they seem like small oversights, but they can unravel the fabric of the entire CI/CD. So they usually smell it. They're like, oh, if they're not caring about this, what else are they not caring about? So in the case of the Nissan incident, they had a Git server, right? Kind of like PHP, which they shouldn't have done that. But they just left all the default configurations, like how you get some software, like the username is admin, the password is password, that kind of stuff. They just rolled it out without changing any of the configurations. And this was accessible to the internet, right? Like, that is not appropriate. Your Git server should not be accessible via public IP address, right? It should be an internal service, and then you should, if you want to expose it to people, have a VPN or another way for your users to get to it. They just rolled out a Git server, public IP address, default config. I don't even have to tell you any more than that. I think you kind of get the idea. But they just left that as an open door, and this incident really illustrates how a single misconfiguration can expose a core IP of a company, right? So you really have to bolster your defenses. You have to do regular updates. Don't use default configuration in your CI/CD tools or your version control platform. If you are rolling out your own, better yet, use someone else's service that's strengthened and is hardened. And yeah, so do the update, follow the principle of least privilege, and secure your default settings. Don't just roll it out without changing that. We used to do that back in the day with applications, but the world has changed. It's funny because you still see that problem in IoT devices. A lot of IoT devices will just have default configs and you can't even change them in some of those devices. It's like when you look at IoT security right now, it's almost like 1999 of web applications. It's sort of like a lot of the same problems are back, but they're in the IoT world or in the CI/CD world, but it's like history is repeating itself. A lot of these things aren't new, but they're just that we're not mindful of them within this particular context. So yeah, follow the principle of least privilege, change your secure defaults to be secure defaults, harden it, and also network access control, right? Like, why was that Git server exposed to the outside? Put some ACLs in front of it, put it on the internal network, make sure that the right network access control in place, and educate and foster a culture of security awareness. Make sure everyone from developers to sysadmins, they understand the implications of weak system configuration on the overall security posture of your company. Really important. So Nissan's oversight should serve as a reminder of the critical importance of being diligent about system configuration. And by implementing these strategies, you can significantly reduce the risk and vulnerabilities on your platform. All right, number 8. Ungoverned use of third-party services. Right? We just let our developers use whatever third-party service. We may not govern it very well, and that can be a problem. So seamless integration, hidden risks. Essentially, as we navigate this ungoverned use of third-party services, we're reminded of the double-edged sword that these integrations can be, right? They offer lots of functionality and efficiency, but also open new avenues for breaches. So there was a company called DeepSource. Some of you may have heard of them. They had an incident. In that example, what they did, the attackers compromised the GitHub user account that belonged to an engineer from DeepSource. And deep source is a static analysis platform. By exploiting the compromised account, the attackers were granted the same permissions as the deep source GitHub application, right? So when deep source clients are using it, a GitHub application is set up, so they got the same level of permission. And that meant that they could access the code base of all deep source clients that had the application installed. This really illustrates the domino effect that can happen when third-party services are not rigorously governed. Bit of a tongue twister there. So what you got to do is to safeguard against these third parties, you should follow the principle of least privilege. You should monitor the access and review and audit them regularly, and also have a vetting process. And know again, it goes back to inventory. Know what third-party services you're using, who has access to them, what level of access they have. And do a bit of threat modeling, right? Threat modeling sounds like a scary and heavy word, but really, we threat model in our lives every day. Like when you get up in the morning and you want to go out, you kind of assess the threat scenario. I might get hit by a bus, or do this, or what should I do? What are the risks? And you take some actions in your day-to-day life. And that's really what this is about. What it's about. Looking at, hey, given this particular system that I'm going to use, this third party, how am I integrating it, and what bad things could happen? Really, that's threat modeling. Is like, hey, I'm using GitHub. If I give all the users access to everything, they can compromise X, Y, Z. You've now done a threat model. It's a little bit more involved than that, but I'm trying to simplify it at a high level. So, these things really help you doing the vetting process, principle of least privilege, monitoring and reviewing regular audits to the activities of the third-party services, and being alert to the changes in the third-party security posture if you're depending on those. But then, of course, always have an emergency plan as well. Make sure you got your incident response plan. And the response plan, just in case a third party that you rely on has a problem or something bad happens. So the deep source incident serves as a critical reminder on the importance of maintaining strict control and oversight over your third-party services that our pipelines use. How many of you are Rick and Morty fans? There are a couple people. I thought I'd put that in there for fun. So basically, the number 9 is improper artifact integrity validation, right? Remember, I just talked about CodeCov. They didn't do any integrity validation of that container or the things that were in it or the bash uploader script. They just let it go. So let's take a closer look at that. And imagine our CI/CD pipeline. It is the backbone of our development process, where every component plays a role, right? So the CodeCov breach revealed a fundamental oversight. A single compromised component, in this case the bash uploader script, could have far-reaching implications. So the key takeaway from the CodeCov is pretty critical to be vigilant about this. And it's not just about doing that initial check, hey, I checked my script is good, but doing that on an ongoing basis. I'm sure CodeCov did an initial check, the script was good, they put it in that Google Cloud storage, but then they didn't do that continuously, right? Like they should have done that continuously, so that did that script get modified since last week when I put it there? So that was lacking. And what are the takeaways there? The takeaways is that it's important to be vigilant in artifact validation. It's not just about that initial check. And that really, looking at the lessons learned is important. And evolving your validation processes, right? So security is not static. It's not just, hey, I set it and forget it. I just did it once and it's okay. You need to do that on a regular basis. It's a dynamic, ongoing commitment. Continuous validation means that you constantly monitor the artifacts for integrity, making sure they haven't been tampered with since their last introduction into the pipeline. So this requires integrating tools. Of course, I know this is complicated, but you got to do it if you don't want to be the next CodeCov. And so you got to continuously scan and alert on discrepancies, making sure that the artifacts remain secure and authentic from the point of entry of their use. And to fortify it further, start with widespread adoption of digital signatures for artifacts if that's possible for you, making sure that each component can be verified as authentic, and make sure you verify the signatures. We did that at HSBC. We're Java shop, everything was signed, we verified the signatures, et cetera, et cetera. But it may not be as straightforward for some other things like your Docker container and whatnot, right? But there's always a solution, and I'm happy to talk to you about it if you're interested. So incorporate continuous monitoring to detect any unauthorized changes, educate your team, of course, and make sure that they're aware of the precedences and things that have happened and learn from them. And again, another lesson that I keep repeating, but is really important. It's also important to maybe once a year at least, or maybe every quarter if you can, have a session with the DevOps team, right? Like, because things change all the time. There are new breaches, new incidents that come out all the time. So doing that regular, hey, let's spend an hour every quarter, get together and look at what happened in the last, what companies got breached, what happened to them. Analyze them and take those lessons and make sure that you implement the right controls so that you can prevent that from happening to you. Last but not least, insufficient logging and visibility, right? So yes, Travis CI was logging too much, right? Like we're putting secrets in there. You don't want to do that, but you want to make sure you have the right level of logging. So let's chat about why keeping an eye on CI/CD pipelines is more than just a good practice. This because it's our lifeline, right? Like if we're using that, we're deploying things. Some companies are using CI/CD to deploy all the way into production if all the gates pass, right? So it's really important to make sure that, the platform is protected. The truth is, the longer the bad actors have the opportunity to explore your system, the more likely there are to actually execute their attack, right? Who remembers the Marriott Starwood breach from 5-6 years ago? It was a big one. What happened is the attackers were doing analysis to see how they can get in for 2 years. And Marriott Starwood, they didn't have the right logging to detect that. And so these guys took their time, they poked around, and after 2 years, they finally figured out what to do, and then they attacked the organization, and lots of data was breached. So this is a lesson for logging and monitoring, because if you were doing your logging and monitoring, you wouldn't have let them go for 2 years. You would have detected that something malicious or anomalous is happening, and you would have nipped it in the butt and stopped them from going further, right? So the longer time they have, the more they can explore your systems more and attack them. And so that's important to make sure that that you're doing the right level of logging. And let me just see here. Yeah, so you want to make sure that you beef up your night vision, essentially. First, centralize the logs. Don't just have them, hey, this system is logging, but centralization gives you that broader visibility where you can connect the dots across different, and maybe they attack your pipelines, and then something else happened in your infrastructure, and something else is happening over there. So if you set up a proper SIM, or use a SIM as a service, or whatever you prefer, that will give you that visibility, but the logs need to get aggregated and aggregated somewhere central. If you don't centralize them, a couple of things could happen. You don't get that full visibility, but also if they compromise your system, they could potentially go and delete those logs. And so that's really important. And another thing that I want to just share with you, don't ever expose your CI/CD platform. Like let's say you've rolled out your own Jenkins. Don't just expose it to the internet, right? Like those CI/CD platforms aren't super secure. So I know some companies, everything is internal, right? So that's fine. They have their CI/CD platform internal, and developers are all internal in the company. But I've seen clients where their developers are working remotely, so they'll just expose their CI/CD, like Jenkins or whatever, to the outside world directly. Those platforms aren't hardened. They're not super secure. They have lots of vulnerabilities. So if you just expose it directly to the internet, you're going to probably get compromised. So what should you do? Put a proxy in front of it. There is actually a proxy for Jenkins. There are other projects out there for other CI/CD platforms, or better yet, don't expose them externally at all. So, so again, real talk from real incidents. Always learn from the past. Make sure that the CI/CD, the Travis CI, and the PHP Git server stories are not just cautionary tales. There are playbooks for what not to do. They teach you the hard lesson that when we're not paying attention, we're essentially leaving the door open and unlocked. And by ramping up the logging game, we keep an eye on things, and we monitor them vigilantly, and we make it that much harder for unwanted guests to stay hidden from us. So in summary, getting our logging and visibility up to snuff means that we're not just reacting to threats after they've done their damage. We're setting up the floodlights and security cameras and making sure that CI/CD pipelines are going to catch the attackers and they don't have anywhere to hide. So conclusion, and then we'll go into QA. So what's the conclusion? So as we conclude this session, I want to reflect on the journey that we've taken from dissecting the high-profile breaches to unpacking the OWASP top 10 CI/CD security risks. As a recap, we've gone through the landscape, and we looked at a bunch of incidents from SolarWinds to Travis CI and CodeCov, and each of them offered a unique lesson on the importance of proactive security measures. And the other thing is the OWASP top 10 CI/CD security risks should serve as your compass, right? Like I said, right after the session, go back to your team, go and grab it, and just go through it with your team. Hey, are we doing these? Are we vulnerable to any of these top 10 issues, right? If you are, you should address it right away. A colleague of mine works at a health tech company, called me up a few weeks ago. Their CI/CD pipelines got compromised. It was a really bad day for them, right? So make sure that you do that initial assessment. Just to start with, set up an hour session, pull up the top 10 list from OWASP, and then just sit down and have that conversation with your team. So that's really important. And then also have a concrete action for pipeline security, right? So the path forward involves taking decisive steps to make sure your pipelines are secure, conduct thorough audits, implement stringent access controls, validate the artifact integrity, establish robust logging and monitoring controls and frameworks. And really embrace continuous improvement. The journey doesn't end here, right? Like it's like, oh, Farshad told us this, we have an hour meeting, we got a list of stuff, right? New attacks in this type of domain are coming up all the time, right? So just because this is the top 10 and you dealt with it today, that doesn't mean something new won't come up later on. So make sure you're always, like I said, regularly visiting the threat landscape, seeing out there what's in the news and who's getting breached and how, and then bring those lessons back to your organization. And by committing to a culture of continuous improvement and security-first thinking, you ensure that your CI/CD pipelines are not only efficient, but they're also secure. So yeah, really, let's move forward with the knowledge and strategies that we've talked today to make sure that we commit to securing our defenses and safeguard our pipelines and build secure fintech applications. And that's the end of the presentation, and I'd like to go into QA if people have questions. And I was told to stay within the line, so I'll stay here. I won't go there, but please, any questions? So, yes, go ahead.
Yeah, what are your thoughts on using YAML scripts to control gating requirements for your CI/CD pipeline?
So do you want to elaborate? So using YAML scripts to automate policies, or?
Yeah, essentially, if you write a YAML script, if your deployment has a critical SaaS vulnerability, it breaks the build, and then you have to fix it to pass the gating requirement.
I'm trying to figure out like which area, because we talked about the top 10, like the types of issues, right? I'm trying to figure out which one of those I would address. Yeah, like can you be more specific? Are we using the YAML script to address like, we can't use it for the identity access management, that's 2FA. For the dependency confusion, we have to lock down the package versions, use our own internal repositories. For the access control is more about reviewing who has access. A lot of those things are things, for secrets management, you have to make sure you're putting them in the right place. They're more things that they're like hardening practices rather than something you would put in. I'm trying to figure out a use case for what you're mentioning. Like automation is always the key, by the way. When you can automate, do it. But I'm trying to figure out which items in this can be automated. Some things like, the flow control, you could try to automate some of that, but that's still at the end of the day, probably there's an aspect of it that involves a manual code review, right? And here's the other thing, you gotta have the right gates in your CI/CD pipelines. If you're not really sure, message me, I've got a reference pipeline security standard that I can send to you. But a lot of companies aren't putting the right gates in the right places. And the gates you should automate as much as possible, but one of the key gates is a manual code review, right? Like when someone does a pull request, you gotta do a code review. Often people don't have it, or if they do, the team lead just goes and looks at it and just clicks OK. They're not reading things properly. So you augment that with a security scanner. But let's face it, security scanner is not going to know context, right? It's not going to know that, hey, this bad guy went and modified the bash script and added something. It's not in the rule set. Not the current security scanners anyways. I'm sure AI security scanners are going to come out. They're going to detect that kind of stuff. But you could automate it through integrity checkers. You're like, hey, this bit of code got added, the integrity breaks, and then this gets flagged to be reviewed. So you could automate some of those things, but I'm not sure exactly how much and what you could do through YAML scripts, to be honest. Thank you. Any other questions? Yes, please.
Not like a direct question, it's more just like, what are your thoughts? But like some of the topics, specifically with GitHub Actions and like the secure repository of artifacts, had me thinking about not so much dependencies, but when we think about external dependencies in the GitHub Action, like maybe AWS publishes GitHub Actions, right? Or you're using third-party GitHub Actions. Like, how do you think about?
So you're using someone else's, like someone has created the action, you're just going to download it and use that, right?
Yeah, like almost like a dependency model, but not.
Yeah, I think I understand. Yeah. Because you're like, hey, do I just blindly use this GitHub action that someone else has created? Should I audit it? Definitely, a manual audit is important because if you just download it and use it, who knows? You use AWS. AWS is hopefully fine, but maybe you use someone else's. It's, you know, small, you go to GitHub and there's someone's project, they've got a pipeline, you're like, oh, this is cool, this could really help me. Make sure you're assessing and seeing what it does. The other thing that you could do is block egress, right? So in your environment, let's say you didn't audit it, and then that pipeline, it runs, and then it's gonna extract some data and send it back to the attacker. So make sure within your network parameter, you've got firewall rules that don't allow stuff to be sent to places you don't know, right? Like legitimately, you might have some bits and pieces that need to call out. So allow those, you know, put them as the allowed IP addresses, but everything else should be blocked, should be denied. So in that case, even if you didn't audit it, you download that pipeline, the pipeline goes and runs and it extracts the environment variables like in case of code and wants to send it back to the attacker, the network access rules are going to block that from happening. But reviewing it and auditing it is probably the best thing.
Yeah.
Thank you. Go ahead.
In one of the topics when you were talking about like, make sure you don't want your secrets.
Sensitive data, yeah.
You mentioned something about
De-identification, yeah.
Can you give a few examples for that?
Absolutely. And it's funny because these are all came from our policies at the bank when I used to work there, because I'm actually seeing the policy right now and it's bringing me nightmares. And it was like, hey, when you're logging, don't put credit cards. We had our like information classification. We had highly restricted, restricted, et cetera, et cetera. Highly restricted information was not to be logged. If we were going to do it, de-identification and tokenization. So de-identification is basically scrambling it to the point that it can't be identified. So if you have, like, let's say, a credential or an API key, you just scramble the characters so there's a bunch of random characters, but it's still the same length. So for your debugging and analysis, you still have something that represents, hey, let's say your credential API keys allow, I don't know, 100 characters. You still have, you scramble that API key into something that's not recognizable, hence de-identifying it. Tokenization was another option where you just put in a random variable, you take the real value, put it somewhere else that's secure, and then you have a lookup table. So you create a token, like a randomized value, and then you substitute in your log, you put the tokenized value. So if you ever need to know what the actual value was, you can go look it up and do that. So, but yeah, encrypting, decrypting is a funny thing because, you know, it just, people, if people are able to decrypt, they're probably gonna get the key from somewhere and decrypt it unless you protect that key, put it in an HSM, which is really complicated to do. So, you know, our policy was just don't log it, and if you're gonna, don't encrypt it, de-identify it or tokenize it. Any other questions? Yes.
If you were a CISO, what are 3 to 5 things that you're making sure are happening in your CI/CD pipeline?
If I were a the most important things you're saying, like what would be the? I would make sure that the permissioning is a problem. Like I said, we do a lot of consulting, and that's where I see people set up pipelines and they're not looking at the permissions. So they got like 6 pipelines, like I was saying earlier. There's a pipeline that's pushing things to staging and it uses API keys that are for staging. That pipeline can also access API keys for production, right? So really looking at the permissioning on your pipelines, who has access and who can do what, that's one of the biggest problems I see. And then, of course, making sure that, you know, you have the 2FA and all the things that we talked about. The flow control is really important, making sure that people can't just change things ad hoc, that there's some sort of gates. And what else would I recommend out of this? Yeah, I think the gates, you know, putting the right checks and balances, access control, those would probably be the most important things that I would consider. And don't roll out your own Git server. 5 years ago, maybe it was okay because GitHub didn't encrypt a lot of this data that was stored. So I remember, unless you got GitHub Enterprise, all the data they kept was unencrypted. So I used to tell people, I'm like, GitHub is not that great, don't use it. This is like 2017, right? But now, I think as of 2021 or 2020, they encrypt all the repos. I think maybe not the public ones, but any private repo now gets encrypted regardless of whether you're enterprise or not. And they got all the other capabilities. So it's pretty good now. But yeah, if you asked me that question 5 years ago, I might have given you a different answer. Thank you. Any other questions? Awesome. Well, I really appreciate you coming here today and, you know, hanging out and listening to this and all the questions. And like I mentioned, feel free to reach out to me. I'm on LinkedIn. You can add me. I think you can scan this. It takes you somewhere to add me and all this stuff. And, you know, I love talking about these topics. I switched from building software to security for a reason because I really like security. And, you know, and I enjoy having the conversations with folks to help them make their applications more secure. If you live in an area where there's an OWASP chapter, I highly encourage you to attend their talks. They have a lot of really good presentations and it's all free. And then in Austin, you guys actually have LastCon, which is an official OWASP conference. and it's also fairly low cost that you can attend. OWASP has like 3 big conferences. One is in DC, one is in OWASP, California, and then the other one is here in Austin. I travel here once a year just for that conference. So I encourage, you guys hopefully all live here, so it's in your neighborhood. Definitely check it out, really good event, and lots of learning. And the OWASP meetups are free too, because a lot of learning from that. And I'm also working on a so me and a colleague from Austin are working on an OWASP project that has controls for securing your pipelines. It's going to be called the OWASP Pipeline Verification Standard. So it's probably going to be launched in the next couple of months, so keep an eye out for it. It'll go more granular than the top 10 here. So this is kind of high level. We break it out into over 100 different specific things that you can do. So keep in touch. Keep your eye out for it. It'll be coming out. And otherwise, thank you for attending and have a wonderful afternoon.